All right, so 1.1 notes, stats basics. We're going to start off with these three goals. One more time. Observational study versus designed experiment. Inferential versus descriptive statistics. And population versus sample. Those are the things we want to take away from today's class. So we'll start with defining population and sample. Population is the collection of all individuals or items under consideration in a statistical study. In the case of the Worldometer, so the activity that we did on Friday, if you were here for that, the population is the...
Sample.
Thanks for trying. World. So that information that was updating constantly represents the population of the whole world. A sample is a part of the population, smaller part, from which information is obtained. For example, given the population of Butler Tech School of the Arts, if we sample 50 people, maybe the first 50 people that walk in the door, then that is, and we give them a survey. Maybe we ask them, are you a morning person or not? That would be a sample of the population of School of the Arts. Another example, given the population of all of Butler County juniors and seniors, the students who attend Butler Tech at this campus would be a sample of that whole population. So that's our sample versus population. We got that. The larger group that we're trying to represent is called the population. And then those that we pull out from that population to sample, that's called the sample. This, two types of statistics is next. So we have descriptive statistics and then inferential. So first, starting with descriptive statistics. So descriptive statistics, the methods for collecting and analyzing, organizing is the word. Collecting and organizing information. For example, the worldometer.com, the world population, underneath that constantly increasing population, there were a few clarifying statements, and they said world population has reached 7 billion on October 31st, 2011. That would be a descriptive statistic. We can make that statement because that statistic already exists. We're not having to make an estimate about what we think the population will be. Question? Okay. And then growth rate reached its peak in the late 1960s when it was 2.09%. So there was a boom in the population in the 1960s. We're going to skip that last one for the sake of time. It includes the constructions of graphs, tables, and charts. May include various measures, calculation of various measures such as averages, measures of variation, and percentiles. And each one of those topics we will go into further in chapters 2 and 3. Flip it over and we'll talk about inferential statistics. The definition here is methods for drawing and measuring the reliability of conclusions about a population based on information obtained from a blank. Yeah, sample. Thanks. Somebody else said that. Sample. So in other words, you are drawing a conclusion about the entire population based on just a sample of that population. So for example, in the Worldometer activity, when they said the days until the end of oil, they took data and they made an inference. Okay, they made a guess that they could estimate the number of days until the end of oil. And similarly, the days until the end of coal. They weren't just reporting a number, they were making an inference, yes. In fact, all of the counters were actually making an inference. So every single one of those counters, the counters are the numbers that were increasing or decreasing. And the reason that that would be an inference is because those numbers are increasing based on an algorithmic program built into that page. So like an algorithm was created to make those numbers increase or decrease at a certain rate based on an equation, right? Based on previous data and information that they're assuming is going to continue, right? This is the rate we think it will increase at, and we're going to keep increasing this number at that rate. So all of those counters were representing inferential statistics. I'm going to have some folks read these bullets below. This is actually, you're going to want to star these. I know it's a lot of words, but how to distinguish between inferential and descriptive statistics. This book is is a great resource, and that's where these two bullet points are from, and a lot of our notes are from this book. If you like a hard copy of a book, I do have 15 copies. If you want to check one of those out, you're welcome to do so. Just let me know. So I'm going to call on someone to read. Sally, thanks.
The purpose of the study is to solely examine and explore information. The study is descriptive. On the other hand, if the information is obtained by a sample of a population, and the purpose of the study is to use that information to draw a conclusion about the population, the study is inferential. Thank you, Ryan. You want me to read both?
Yeah, you're doing a great job.
A descriptive study may be performed either on a sample or on a population. Only when an inference is made about the population based on the information obtained from the sample does the study become
Thanks, teamwork, I like it. All right, thanks. So this is a good reference point. We've read them out loud. Sometimes when you reread it, right, it starts to sink in more. But basically, you have descriptive statistics are just communicating the data. Inferential statistics are looking at data and making an inference, drawing a conclusion, making an assumption. All right, the last section is observational study and design experiment. So in an observational study, researchers simply observe characteristics and take measurements as in a sample survey. So someone is observing data that already exists. For example, if I said, if your shoes have ties on them, if your shoes have strings on them, stay seated. If your shoes do not have shoestrings, stand up. No shoestrings. All right. So if I look around the room, data already exists. Thank you. You guys can have a seat. So I just counted, and there were 10 people that stood up, and there were 15 people still seated. And that is an observational study. I just quickly did a survey of the room about data that already exists. Oh, goodness. Design experiment, on the other hand, different. So researchers impose treatments. This sounds a lot like science class. There's a lot of overlap you'll see between the two. Impose treatments and controls, and then observe characteristics and take measurements. So you'll see some of the same words, observe and take measurements. The key here is we're establishing cause and effect. So the data do not exist. So data is one of those words where it's the same singular as plural. So that's a correct statement grammatically. I know it sounds funny. The data do not exist until someone does something, the experiment, that produces the data. So here's one of those statements, again, that kind of helps you distinguish between the two. Observational studies can reveal only association, whereas a designed experiment can help establish causation. So why does this thing happen? You can kind of help establish a cause when you're doing a designed experiment. Question? All right, that concludes our 1.1 note.